So what this means is that we are going to graph just this one little piece right here. This is the part that we're going to graph the inverse of. For cosine, this is the piece we're going to graph the inverse of for sine, and this is the piece we're going to graph the inverse of for tangent. Okay, so as I go through here, remember for inverse, you switch x and y, which means now on the x-axis, I'm going to have my -1 and my 1, and on my y-axis, I'm going to have my pi and my 2 pi, and pieces in between, my -pi and my -2 pi, and I'm only going to have that one little piece of my function. Okay, now what I'm going to do to kind of help us see how we would get this, I'm actually going to turn my paper like this. And if this was a regular cosine graph, what I would do is I would start here, and I would have my curve come down and back up like that, and I'd have my curve come down, back up like this, like that, if I did the entire thing. Okay? But obviously, I don't want the whole thing. I only want the piece that goes from 0 to pi. So when I'm going from 0 to pi, that's just here. That's the only piece that I want. So all of this is actually not there, which then makes it pass the vertical line test. So that is my inverse cosine graph. Okay. For my inverse sine, rather than having us draw the sine and then erasing, I'm just going to show you that my inverse sine graph, so we're taking this piece here, and we're switching x and y. And remember, my restricted domain goes from -pi/2 to pi/2. Okay. So let's see, if this was, let's say this was pi, this would be pi/2, and this would be -pi/2, this would be -pi. Okay, so I'm going from -pi/2 to pi/2. If I do that one piece of the graph, my curve would look like that, because the rest of my sine curve would go like this. You see how I would have the rest of my sine curve would be like that. I'm not going to have that part though, because then it's not a function. I'm just looking at that piece for sine. Okay. And then for the tangent, same thing. I'm just going to go -1 and 1, and I'm going to have pi/2. This would be pi. This would be -pi/2. This would be -pi. Now remember, my pi/2s, I have those asymptotes. And because of the asymptotes there, when I say what x can be, I need to take out those equal signs there, because it can't actually equal pi/2, because that's where the asymptotes are. And then remember, it always bends towards the asymptote, like that. And notice, when I'm looking at just this piece, it passes the vertical line test. So now the inverses are indeed functions, but I have a restricted domain. We're going to go through and we're just going to do a little bit about domain and range for each one of these. And I also want you to know that another name for inverse is y equals the arc cosine of x. Y equals the arc sine of x. The word arc cosine and inverse cosine are the same thing. It's just another term for it. Y equals the arc tangent of x. So those are just other names for it. The domain obviously goes from -1 to 1. And the range is from 0 to pi. Notice up here, this was the domain, so down here it's the range, because this was on the original. So remember, with inverses, domain and range switch. So here my domain, I look at my graph, goes from -1 to 1, and my range is from -pi/2 to pi/2. When I come to my tangent, my domain goes forever and ever in both directions, is all reals. And my range goes from -pi/2, don't put equal to though, because you have asymptotes there, to pi/2. You may be feeling confused right now, or frustrated that maybe you don't understand this. All we're saying is that in order for us always, for it to be a function, to always all get the same answer, we have to say, okay, we're only going to look at this part of the unit circle to get our answers. Otherwise, when we do an inverse, I could be giving an angle from quadrant 1, and you could be giving an angle from quadrant 2, and they're both correct, but we want there to only be one correct answer. So we're limiting it, and we're saying that when we find an inverse cosine, we're only going to look in quadrants, as we saw up here, what ends up being quadrants 1 and 2. All of my answers are going to be between 0 and pi, or 0 and 180. If you give me an answer for inverse cosine that's bigger than 180, you know it's wrong. For inverse cosine, all your answers have to be between 0 and pi, or 0 and 180. For inverse sine, you can't give me an answer like 150 degrees. It has to be between -pi/2 and pi/2, or -90 and 90. Can't go outside that range for inverse sine. For inverse tangent, same thing as inverse sine. You have to be between -pi/2 and pi/2 for your answers, or -90 to 90. Maybe we should also put that 0 to 180, -90 to 90. If you, for an inverse, give an answer outside that range, you know that your answer is wrong, automatically. So let's go to the next page and see how this affects when we solve problems. So what you're doing here is you're going to be looking at your unit circle. And what you have to remember is for inverse cosine on the unit circle, the only place that you can get your answers from are quadrants 1 and 2. And then for inverse sine, and inverse tangent, we're in these two quadrants. However, this quadrant here is going to be negative of whatever this quadrant is. So in other words, I'm going to draw it over here a little larger. We have pi over 6, which means down here we have negative pi over 6, which I think makes it easier. I don't have to remember 11 pi over 6. This is pi over 6. This is negative pi over 6. This is pi over 4. This is negative pi over 4. This is pi over 3. This is negative pi over 3. This is pi over 2. This is negative pi over 2. And this is still 0. Okay? So this is what I have for inverse sine and tangent. Okay? So let's think about inverse cosine of square root of 3 over 2. So we're asking ourselves, where is cosine the square root of 3 over 2? So I can look at my unit circle, come to my unit circle right here. Where is my cosine the square root of 3 over 2? Right here. And let's do all radians for right now, which means my answer is pi over 6, which is I'm only looking at these two quadrants. So when I answer an inverse cosine question, I'm not even paying attention to this down here. All my answers are only coming from here. So it's pi over 6. Let's go to number 2. Inverse sine of square root of 2 over 2. Inverse sine. So where is sine square root of 2 over 2? I look at my unit circle, and because it's inverse sine, I'm only looking at the right side of the unit circle. And these answers down here are no longer, this is negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2. So sine is the y coordinate. Where is it? Square root of 2 over 2. And I see that right here at pi over 4. So I get pi over 4. Okay. Let's go to number 3. Arc sine is the same thing as inverse sine of 0. So where is sine 0? That's what it's asking. Sine is the y coordinate. Again, with inverse sine, I'm only looking at this side of the circle. Where's my y coordinate 0? Right there at 0. Inverse tangent is 1. So it's asking where is the tangent 1. So I'm going to look at my unit circle. Inverse tangent is only on the right side. I don't want to look at this side of the unit circle at all. This side does not exist. Where is the tangent 1? See it right there at pi over 4. Number 5 says inverse cosine of negative square root of 2 over 2. So where is cosine negative square root of 2 over 2? So since I'm looking at cosine, cosine is the top of my unit circle. And I want it to be negative square root of 2 over 2, which is right here at 3 pi over 4. Inverse sine negative. So where is sine negative square root of 3 over 2? So I go to inverse sine, which is only on this side of the unit circle, and it's negative right down here This would be called negative pi